You've seen those wild videos of humanoid robots, right? It's mind-blowing stuff. But if you think the big money is in building the best robot, you might be missing the real trillion-dollar story. NVIDIA is quietly executing a strategy to become the one company every robot manufacturer on Earth has to pay. They're not building the parts, they're building the brain. And today, I'll show you exactly how they're doing it and what it means for the future of robotics ETFs. This isn't science fiction. This is happening right now. NVIDIA's CEO, Jensen Huang, has been crystal clear. After AI, robotics is the next multi-trillion-dollar opportunity for the company. He's not just talking about better graphics cards. He's talking about building the entire operating system for physical embodied AI. His vision is a future with billions of robots and millions of autonomous vehicles, all powered by NVIDIA technology. We're in the middle of a huge shift. We're moving from rigid, single-task robots into an era of physical AI, where machines can perceive, reason, and act on their own in the messy real world. The robotics industry just had its ChatGPT moment, and while everyone is scrambling to find the next breakout company, the real story, the real investment, is in the platform that will power them all. We're going to look at the three pillars of NVIDIA's robotics strategy. First, the brain, the AI foundation model known as Project GR00T that gives robots intelligence. Second, the training ground, the virtual world of Omniverse where these AI brains are taught at impossible speeds. And third, the engine, the specialized hardware, from giant data center GPUs to tiny computers inside the robots themselves, that makes it all work. Finally, we'll tie this all back to what it means for you as an investor and how it changes the game for robotics funds like the Global X Robotics and Artificial Intelligence ETF. This is how NVIDIA plans to build the foundation of the next industrial revolution. To really get what NVIDIA is up to, we have to start with the huge problem they're trying to solve. For decades, factory automation has been all about efficiency, but it's always had one massive limitation: it's dumb. A traditional factory robot can perform one task with superhuman speed and precision, but ask it to do anything else and it's useless without a complete reprogram. That rigidity is a huge bottleneck because the real world isn't clean, predictable, or stable. It's messy and chaotic, and that old model is starting to break down. We're facing global labor shortages, and our supply chains are incredibly fragile. There's a massive push to bring manufacturing back home and build more resilient industries, but you can't build the factories of the future with the automation of the past. You need machines that can adapt, work with humans, and handle the unpredictable real world. This is the challenge that's held robotics back. It's a data problem, a learning problem, and a computing problem all at once. How do you teach a machine to understand physical space? How does it learn to pick up an object it's never seen? How does it navigate a crowded warehouse without causing a disaster? This is where NVIDIA's vision begins. Jensen Huang and his team saw that this wasn't a mechanical problem anymore. It was an AI problem. The answer wasn't a better robotic arm, it was a better brain. This insight led to the declaration that we are at the ChatGPT moment for robotics. And that's a perfect analogy. Think about it. Before ChatGPT, AI language models were narrow. You had one model for translation, another for summarization. They were good at one specific task, just like a factory robot. But the breakthrough of large language models, LLMs, was the creation of a foundation model, a single massive model that could be adapted to do almost anything, from writing poetry to coding. It wasn't programmed for each skill, it learned them. NVIDIA's plan is to do the exact same thing, but for the physical world. Instead of training on internet text, their models are trained on the physics of reality itself. They're building a foundation model for movement and interaction, and AI that can be downloaded into any robot on any hardware and give it the ability to understand and execute complex tasks in the real world. This is physical AI. This vision completely changes the robotics industry. Robot companies no longer need to solve the impossible problem of creating general AI from scratch. They can focus on building amazing hardware, a humanoid, a robotic arm, an autonomous vehicle, and then license the brain from NVIDIA. It's a platform strategy NVIDIA has perfected before. With its CUDA programming language, NVIDIA created an ecosystem that made its chips the default for the AI revolution. They're now doing the same for robotics, creating what could become the Windows or Android for every intelligent machine on the planet. This is the grand vision. It's not just about selling more chips. It's about becoming the central nervous system for a future of autonomous machines. It's a strategy designed to make NVIDIA indispensable, capturing value from every robot that gets switched on. So how does NVIDIA turn this vision into reality? It all comes down to a deeply connected three-part strategy. Think of it as a complete operating system for building and deploying intelligent robots. It's made of the brain, the training ground, and the engine. Pillar 1, the brain, Project GR00T and the quest for general purpose robotics. At the very heart of this strategy is the brain, Project GR00T, which stands for Generalist Robot 00 Technology. The name says it all. This isn't just another narrow AI. GR00T is a foundation model designed to be a general purpose brain for humanoids and other smart machines. It's built to understand natural language, watch and learn from human actions on video, and turn that understanding into real-world robotic movement. Think about how huge this is. A manager could one day just tell a robot, unpack that pallet, check the items for defects, and stack the good ones over there. The GR00T model would understand the command, use its knowledge of objects and physics, and generate the complex actions needed to get it done. This is the end of programming as we know it, and the beginning of teaching. So how does it work? GR00T is a multimodal model, meaning it understands text, speech, and video all at once. It learns by watching. You can show it videos of humans doing tasks, and it learns to mimic those actions through a technique called imitation learning. To speed this up, NVIDIA even has workflows where a human can control a robot using something like an Apple Vision Pro. The human's movements are recorded, creating high-quality data that's fed into the model to create vast training data sets. NVIDIA isn't trying to build all the robots. Instead, it's providing GR00T to leading robotics companies like Boston Dynamics, Agility Robotics, and Figure AI, who are integrating the GR00T brain into their hardware. It's a classic platform play. NVIDIA provides the core intelligence, and its partners innovate on the physical form. This creates a massive ecosystem that speeds up progress for everyone. With NVIDIA right at the center, GR00T is the AI part of the equation. But a brain, no matter how powerful, is useless without experience. And that brings us to the second pillar. Pillar 2, the training ground, NVIDIA, Omniverse, and synthetic data. What's the biggest thing holding robotics back? It all comes down to one word: data. To learn how to operate in the real world, a robot needs to experience it. This used to mean thousands of hours of slow, expensive, and dangerous physical trial and error. NVIDIA's solution is brilliant. They decided that if the real world is too slow for training, they would just build a perfect simulated copy of it. This is NVIDIA Omniverse. Omniverse is a platform for creating physically accurate, photorealistic virtual worlds, often called digital twins. Think of it as the world's most advanced video game engine, but for industrial use. Companies like BMW and Amazon Robotics are already using it to design and simulate their factories before a single brick is laid. The real magic for robotics comes from a tool called NVIDIA Isaac Sim. It allows developers to drop their robot models into these hyper-realistic digital twins and train them. A robot can live inside the simulation for millions of hours in a fraction of the time and at virtually zero cost. And this is where things get truly mind-bending: synthetic data generation. Inside Omniverse, NVIDIA can create a nearly infinite stream of perfectly labeled training data. They can change the lighting, move objects, and create unexpected events. This process, called domain randomization, makes the AI incredibly robust, so it can handle new situations when it's finally deployed in the real world. This closes the simulation to reality gap, ensuring that what a robot learns in the virtual world actually works in the physical one. The impact here is massive. Development timelines that took years are being compressed into months. A startup doesn't need a giant warehouse to teach a robot a new skill. They just need NVIDIA's simulation platform. This creates a powerful moat for NVIDIA. The more companies that build their workflows around Omniverse and Isaac Sim, the more essential the platform becomes. Pillar 3, the engine, the two-pronged hardware strategy. NVIDIA's entire ecosystem is built on a foundation of silicon. The company's dominance comes from its mastery of the GPU, and its robotics strategy is a brilliant two-part hardware attack. The first part is the data center. This is where the heavy lifting happens. Training models like GR00T and running Omniverse simulations requires a staggering amount of computing power. This is the job of NVIDIA's most powerful data center GPUs, like the new Blackwell architecture. These are the massive engines that power the AI factories where robot brains are created. The more complex the robots, the more simulation they need, and the more data center GPUs NVIDIA sells. But a robot can't be chained to a data center. It needs its own brain on board. This is the second part of the hardware strategy, edge computing, and the flagship product here is the NVIDIA Jetson platform. The newest version, the NVIDIA Jetson AGX Thor, is a supercomputer on a module, a compact, power-efficient computer designed to be the brain inside a robot. Crucially, it's powered by the same Blackwell GPU architecture found in the data centers. This means AI models trained in the cloud can run seamlessly on the chip inside the robot. Jetson Thor delivers a massive 7.5 times performance increase over its predecessor, all within a power budget that works for a battery-powered machine. This is the power needed to run complex AI models for perception, navigation, and manipulation, all in real time. More than 2 million developers are already using NVIDIA's robotics stack, and early adopters of Jetson Thor include a who's who of the robotics world, from Agility Robotics and Figure to industrial giants like Caterpillar. This two-part hardware strategy creates a perfect self-reinforcing loop. The demand for smarter robots drives the need for more powerful data center GPUs. Advancements in those GPUs are then scaled down into more efficient Jetson modules. The robots then collect new data from the real world, which is sent back to the data center to improve the AI models. It's a closed-loop system where NVIDIA owns the critical hardware at every step. Okay, we've gone through the tech, we've seen the master plan. So what does this all mean for your money, and specifically for an investment in a robotics ETF? This is where the picks and shovels investment idea comes to life. During the gold rushes, the people who consistently made the most money weren't the prospectors digging for gold. It was the people who sold them the picks, shovels, and blue jeans. They profited from the entire gold rush, no matter who struck it rich. In today's gold rush for robotics, NVIDIA is positioning itself as the ultimate seller of picks and shovels. Hundreds of companies are competing to build the winning robot. Some will build humanoids, others will focus on logistics or surgical bots. It's incredibly difficult to predict today which ones will succeed. Investing in a single robotics startup is a high-risk bet. An alternative is an ETF like the Global X Robotics and Artificial Intelligence ETF, which trades under the ticker BOTZ in the US. An ETF like this gives you diversified exposure to the whole industry by holding a basket of companies. Now let's look under the hood of an ETF like BOTZ. You'll see names you'd expect, like Intuitive Surgical and the Japanese giant Fanuc. But towering over all of them as the single largest holding is NVIDIA, often making up over 11% of the entire fund. This is crucial. When you buy $BOTZ, you're not just betting on a collection of robot makers. You're making a big, concentrated bet on NVIDIA as the key enabler of the entire industry. Your investment is directly aligned with NVIDIA's platform strategy. But it goes deeper. Think about the other companies in the fund, automation companies like ABB, drone makers, and autonomous vehicle suppliers. They all face the same challenge, making their machines intelligent. And as we've seen, NVIDIA is building the most powerful platform to solve that problem. it's very likely that a huge percentage of the other companies in the BOTZ ETF will become NVIDIA customers. Their success will depend on NVIDIA's platform. This structure reduces risk while keeping huge upside potential. If a small robotics company in the ETF has a breakthrough using NVIDIA's platform, the fund's value goes up. If it fails, the loss is cushioned by the other companies. All the while, the foundational enabler, NVIDIA, keeps growing by selling its picks and shovels to everyone in the game. It's a bet on the trend, not a single horse. Of course, no investment is a sure thing. A few threats could derail this strategy. First, competition. While NVIDIA has a huge lead, other tech giants aren't standing still. Companies like Tesla are developing their own AI, hardware, and robots completely in-house. Other cloud providers could try to build competing platforms. Second, there's execution risk. This strategy is incredibly ambitious, and there are still major hardware hurdles in robotics like battery life and actuator costs, which are outside NVIDIA's control. Finally, there's valuation. NVIDIA's success is no secret. An investment today is a bet that this massive future growth isn't fully priced in yet. However, the bull case is compelling. NVIDIA is creating a deep technological moat with its interconnected pillars: the brain, the training ground, and the engine. The robotics and automotive division is still a small part of NVIDIA's total revenue, but it's growing fast, with some reports showing significant year-over-year growth. This suggests the story is just getting started. So let's pull this all together. You've seen the impressive robot demos, but the real story isn't the robot itself. The trillion-dollar strategy from NVIDIA isn't about building the best robot. It's about building the universal brain that powers every robot. We've seen how their strategy stands on three pillars: the brain, Project GR00T, a general-purpose AI to give robots human-like intelligence; the training ground, NVIDIA, Omniverse, a virtual world for training those brains with synthetic data; the engine, a hardware 1-2 punch with Blackwell GPUs for training and Jetson Thor for deployment. This isn't just a collection of products, it's a complete operating system for the next industrial revolution. NVIDIA is making the ultimate picks and shovels play, positioning itself to profit from the entire robotics gold rush. For an investor, this reframes the whole opportunity. An ETF like BOTZ is no longer just a bet on robot makers, it's a direct bet on NVIDIA's platform strategy. You're investing in the company building the indispensable foundation for the entire industry. The race for robotics isn't about who builds the best hands, it's about who builds the brain. And NVIDIA is betting $1 trillion that it will be them. The shift from programmed automation to true physical AI is here, and NVIDIA is holding the map. If you want more deep dives into the technology and investment strategies shaping our future, make sure to subscribe.